point question is the math question. Fatigue question can be a big point question as well. I think what else is a big point question? The lung volume graphs, there can be a lot of points. That's another graph that we did. Go ahead.
For that lung volume graph, are we gonna have to like label and define the terms? Or
So defining them will be separate. Drawing the graph and labeling it is one thing, and definitions will be separate. Okay, let's start with that. What is this one?
Vital capacity.
Okay, what is this one?
FRC.
Functional residual.
Good. What is this one?
Expiratory.
What is this one?
Inspiratory. Capacity.
Capacity. What is this one?
Reserve.
This one?
Total lung capacity.
Okay, then this one.
Residual volume.
You guys are amazing. Okay. What are the four parts of respiration? Okay. Can someone please explain the process of inspiration? Zoe, go ahead.
Chiropractic the diaphragm is a curve, and so when we're gonna breathe in, it's gonna contract and it's gonna flatten out. Because of that flattening out, the lungs are gonna build more, are gonna have more space, which means you're gonna have a bigger volume, which means that the pressure is gonna decrease, and the outside pressure is gonna stay the same, but because the pressure gradient is different, the outside air has more pressure, so therefore it's gonna come into the lungs, and this kind of like affects, or what's happening is the boils law. And when you breathe out, the lungs will go back up, the volume's gonna decrease, the pressure's gonna increase, and then go the other way on the pressure gradient.
Okay, very good. Make sure when you're mentioning Boyle's Law, it's not an afterthought. When you talk about the lungs expanding and increasing in volume, causing a decrease in pressure, that's when you should mention Boyle's Law, because that's where it applies. Do you understand the difference? Rather than mentioning at the end, mention it where it applies. Good. Any questions on that? Okay. What are the four parts of the respiratory membrane? Basement membrane, capillary walls, capillary basement membrane. Tell me two things that can make the gases diffuse faster.
High O2, partial pressure, low carbon dioxide, partial pressure.
So the partial pressure gas gradient is one, and the other one is
Increase in surface area.
the surface area. What law is that?
Henry's.
Fick's law. The rate of diffusion is proportional to the surface area and the partial pressure gas gradient. That's Fick's law. So rate of diffusion is how fast the gases diffuse. What is Henry's law? Gases dissolve in liquid in proportional partial pressure. What is Dalton's law?
The sum of
Some
all
are
blood
pressure.
Pressure. Good. So will oxygen diffuse from the lungs into the blood faster at rest or during exercise? Yes, why? The gradient's higher because
There's less O2.
there's less oxygen in the blood because
You use it.
the muscles consumed it. So the blood that's coming back through the lungs has less oxygen in it, therefore there's a larger gradient, which just means there's a bigger difference, which is one of the things that makes the gas diffuse faster. Good. Any questions on that? Yes?
So that we don't have to like explain any laws or anything like that, we just have to say it how you said it on that.
For that question I just asked? Yeah. Okay, what is the Bohr effect?
The lower the, or lower pH means lower, percent hemoglobin saturation.
Okay, and why is that important?
Good question.
Go ahead.
It's important because when you're at the muscles, they will have a decrease in pH. So therefore, we want the hemoglobin to release more oxygen there and not anywhere else.
Good. Causes the hemoglobin to release oxygen at the exercising muscle. Same with the temperature and the PO2. Those are conditions that are causing the hemoglobin to release the oxygen there. So if we're drawing the Bohr effect, what goes on the x-axis?
PO2.
Okay, what goes on the y-axis?
Percent hemoglobin saturation.
Okay, so if I'm drawing the curve for normal for normal pH, when PO2 is low, saturation is,
Low.
when PO2 is high, saturation is,
High.
and sigmoid curve, this has gotta be labeled low, medium, high, at least. And when I draw this normal pH, when I draw the curve for low pH, where is it gonna go? Lower, so it's in 446, they'll call this a shift, bless you. They'll call this a shift to the right. The hemoglobin saturation curve shifts to the right. And that is low pH. Okay, what is AVO2 difference? Difference in the oxygen content between the artery and the vein, and what does that tell us? Which oxygen the muscle consumes. So when we increase our exercise intensity, we increase our oxygen consumption, so what happens to AVO2 difference? Up or down?
No, take it out.
If I have, at rest, if I have 20 coming in and 15 coming out, I consumed 5. During exercise, if I have 20 coming in and 5 coming out, I consumed 15. So what happens to AVO2 difference as exercise intensity increases? It increases. There's a bigger difference between the oxygen content of the artery and your oxygen content of the vein because the muscle consumed more. We okay on that? Okay. We okay on the hemoglobin saturation curves, the myoglobin saturation curve?
Can you explain the myoglobin saturation?
Myoglobin, sure. When we draw the myoglobin saturation curve, we also draw the hemoglobin saturation curve to compare. So it's going to be PO2 and what goes on the x-axis? Just percent saturation, not hemoglobin saturation, because I'm going to draw one curve for hemoglobin and one curve for myoglobin. So it's going to be the same hemoglobin saturation curve. This is going to be low, medium, high.
Can we label it like that in the exam? L and H?
No, please don't. I probably won't mark off for it, but it will make me grumpy. Myoglobin saturation curve goes where? So myoglobin saturation stays high. Even as hemoglobin's losing its affinity for oxygen, myoglobin still wants it. So hemoglobin's going to release it, myoglobin is going to pick it up until it gets to the mitochondria where it's going to drop it.
This graph is for which one is it?
I'm sorry?
Which one is this graph for?
This is the myoglobin saturation curve, but we also draw the hemoglobin saturation curve at the same time so we can compare them. Okay. Anything else from this chapter you want me to review? Okay, let's do some math review. I'm going to do an easy, a medium, and a hard.
Gas. Two T's.
2 T's and an E.
Really?
Yeah.
I'll give you the formulas that will be given on the test. Raise your hand if you have the answers. Raise your hand if you're stuck. Raise your hand if you need more time. Raise your hand if you have the answers. Okay, raise your hand if you're stuck. Okay, raise your hand if you need more time. Okay, I'll give you like another minute. Riley, are you stuck on the last one?
Yeah.
All right, let's start going through the first couple. So where should I start?
Convert,
Convert pounds to kilograms, okay, did that.
find your 70% of the
Okay, so I need to take 70% of this. That's 33.6. What's the unit on that?
millimeters per liter.
Okay, and if I had to label this, what would I call it?
VO2 submax.
Okay, I strongly recommend you keep units on your numbers and keep them labeled and organized. So we have a VO2 max and we have a VO2 submax. Now what do we do? I'm gonna plug in the submax number to my running formula and solve for speed. Okay, so I'm gonna put 33.6 here. 0.2 times the speed is what I'm solving for. The grade is gonna be 0, so this whole piece is gonna be 0 plus 3.5. Okay, so I'm gonna subtract 3.5. I get 30.1 equals 0.2 times S, and what do I do? Divide by 0.2. That gives me 150.5. What is that?
Meters per second.
Meters per minute. How do I convert it into miles per hour? 26.8. I got 5.62 miles per hour, which you could just you leave as 5.6. I'm okay with doing miles per hour to just one decimal place. This is more practical. Everybody okay with that?
Yeah.
Okay, so if I want her at 70% of her VO2 max, it means I want her running at 5.6 miles per hour on flat ground. If she does that for 15 minutes, how do we figure out her energy expenditure?
Check her VO2 submax and check it out and shoot the calories.
So 33.6. Okay, common error here is to use the 48, but I guarantee she's not running at her VO2 max for 15 minutes. You've got to use the submax. So ml, kg, minute. This is when we do this or use the latter. So what do I do?
1 meter.
Kilograms go here, 63.64. What goes here?
5 kilograms per liter.
For liter, I'll be looking for this unit. And 15 minutes. Alright, plug all that into your calculator. What do you get? 160,
160.37.
like that? Okay, what's the unit? Good. Any questions on that one? If you have questions, now's a great time to ask. Okay, I'm guessing the heart rate one is where most of you got stuck. Okay, so we need to use the swing formula. If you know what percent VO2 max she's at, you can figure out what percent of her heart rate max she's at. Okay, what percent of her VO2 max is she at?
70.
Okay, so I'm gonna do 0.64 times 70 plus 37. Can someone tell me what that comes out to? 81.8, and this is percent heart rate max. Common error is to just put that as the heart rate. Slap a beats per minute on it and be done. That doesn't make any sense. We're trying to figure out if you're at 70% VO2 max, what percent of your heart rate max are you at? So, she's at, we expect her to be at about 82% of her heart rate max. We need to figure out her heart rate max. How do we do that?
208 minus 0.7 of each.
Okay, this formula will not be given to you. That's a formula I expect you to know. So 208 minus 0.7 times 35. What does that turn out to be? 193.5. 183.5 unit. This is beats per minute. This is heart rate max. Now what do I do?
Heart rate max by
I gotta take 81.8% of that. So I multiply by 0.818. What does that turn out to be?
150.3 beats per minute.
So I'll just say 150 beats per minute, because I'm not counting thirds of heartbeats. Okay, those of you who got stuck, understand where you got stuck, how to get past it? Okay, any questions anywhere on there?
Should we expect this format on the test?
Yes. I'm gonna give you a slightly harder one now. This was the easy one. No, that was easy. I'm not gonna put an energy expenditure one on here because it sounds like you guys are okay with that. Should I do another heart rate one, or are you guys okay with the heart rate? Okay. one's gonna make you 15 years old.
I advocate.
Do I look 35?
No, I was like, I'm just joking.
I'm a little offended. Most of the state for is 26.
Raise your hand if you have the answers. Raise your hand if you're stuck. Raise your hand if you need more time. Okay, if you got an answer for the first one, what is his VO2 max? Tell me what you got. 40? 50?
His VO2 max is 50, yeah.
So some people got 40, some people got 50?
It's because the VO2 is 40 from the
40 is
ACSM
the
running
sun.
formula, and then when you times it by 80, it's 50.
Okay, anybody get something different? So did you guys get the 40 or the 50 as your answer? 50, okay. So where do we start?
Plugging,
Okay, so to start the running formula, this time I gave you a speed and a grade and we need to solve for VO2. So what do I plug in for speed?
160.8.
So I needed to do 6 times 26.8 and I got 160.8 plus 0.9 times 160.8 times what?
0.03.
0.03, common error here is to put 0.3, which would be a 30% grade, plus 3.5. Okay, and we end up here with 40,
32.16.
32.16 unit,
Miles
By
per hour.
meters per minute.
No, meters per
oh wait, sorry. Let's do this together.
If that's,
Let's
the
do this together.
160.8 is meters per minute.
0.2 times 160.8. Okay, 32.16 plus 160.8 times 0.03 times 0.9,
4.8.
4.3416
5.
plus 3.5 plus 32.16, where we get the 40. That's what I meant. Okay, so that's the submax VO2 of what he's running at. It's the VO2 requirement of what he's running at. How do we figure out what his VO2 max is?
Divided by 0.8.
0.8. How did you know to divide?
You're getting
Because most of the
80%.
time we find
Yeah, if you were to multiply this by 0.8, you'd be taking 80% of this and you'd get a lower number. Which if you do that, you should automatically realize if you're thinking about what you're doing and not just going through motions without thinking about it, which a lot of people do. If 40 is 80% of his max, it doesn't make sense for his max to be something lower than this. So if you get something lower, you need to realize you did something wrong if you're paying attention to what you're actually doing. Okay, so what you're trying to figure out is 40 is 80% of what? Like what do I need to multiply by 0.8 to give me 40? So you're gonna divide by 0.8 instead of multiplying. And that's how we end up with 50. Okay, is everybody okay with that?
Yeah.
yes.
Okay, so the heart rate one, what do we plug in?
Percent.
80%.
We're gonna plug in 80 for the VO2 max. Remember, for this formula, we use whole numbers, not decimals. So I gotta do 0.64 times 80 plus 37, and what does that tell us? 88.2% heart rate max, but we need to figure out his heart rate max. What's the formula?
So 8 minus 0.7 of H.
So we're gonna plug in 24 here, and what do we get? 1.2 beats per minute, heart rate max. Then what do I do?
Multiply by
0.882, and what do I get?
168. So 168.
Like this?
That's, yeah.
Okay, so 169 beats per minute. Yes,
On the test, if we leave it, the 168.64, would we get a point deduction?
I will mark that out, but I don't like to deal with fractions of heart rate, heartbeats.
Oh, you didn't.
Any questions on that one? You good? Okay, I've got one more for you.
section, bro? Are we supposed to assume he's working his VO2 medicine?
your hand if you have an answer. Raise your hand if you're stuck. Raise your hand if you need more time. All right, where should we start? We can't start with the running formula because we don't have anything to plug in there. If you plug in the VO2 max there, that's not gonna help you. All that's gonna tell you is what speed he would be at for his VO2 max. That's not helpful. So what do? If we have a submax heart rate and we have his age, we can figure out what percent of his heart rate max he's at. That gives us something to plug in here. Then we can figure out what percent of his VO2 max is. We can take that percent of that and plug it in there to find the speed, okay? So, how do we find heart rate max? And what do we get?
192.6.
Okay, so I'm gonna say 193 beats per minute is heart rate max. How do I figure out what percent of his heart rate max he's at? You gotta do the sub-max divided by the max. This is math I expect you guys know how to do. If you have a sub-max and a max, you can find a percent. Just like if you know your score on the midterm and you know the total points possible, you can figure out your percent. It's always the sub-max divided by the max, give you your percent. So what does this turn out to be?
71.98%.
71.18,
98,
like that?
Yeah.
So what you got was 0.71,
No, I got 20.
that's percent
Yeah.
yeah, this is what you got, and so you're making it 71.98%, right?
No, that's his percent VO2 max.
That's the percent.
Yeah.
83.07% of heart rate.
Oh,
It's
Yeah,
0.82.
Yeah, it's
Yeah.
160 divided by 193
82%.
is 0.8290, which is 82.9% heart rate max. Yes? Okay, now we plug that in here. So every other time we've used this formula, we've been plugging in percent VO2 max and solving for heart rate max. But we can do it the other way. We can put in 82.9, because in this formula we use the whole number, equals 0.64 times what we're trying to figure out, plus 37. Now what do I do? 82.9 minus 37, 45.9 equals 0.64x. What do I do?
divided by 164.
This is 71.72, what? This is percent
Of VO2 max.
VO2 max. because we were solving, that's what we were solving for. So you gotta keep track of what you're solving for, keep your numbers straight. This is not a beats per minute, this is not an ml per kg per minute. This is percent VO2 max. Now what do I do?
Plug it into the.
Not yet.
Oh, we have to figure out.
You have to give that-
I gave you a VO2 max, so I've gotta take 71.72% of that. What does that give me? $59 times 0.7172. 42.31. Is that what you guys got?
I got 42.47.
I think it's
Wait.
because we put the 83%
Yeah.
instead.
That's what I was gonna ask, would you give points for like a rounding error, cause some people round early, some people round late?
So you used 83 here?
Yeah, we got 83.07 in
It's because we didn't round it up yet.
Yeah, I didn't round it to 193, I rounded it to 192.6 in the beginning,
Yeah,
from
same
when I
here.
divided
The heart
160,
rate max.
the heart rate,
Okay, so with the rounding you did, what did you end up with here?
42.38,
That's
or
totally fine.
48.38.
48.38 is too far.
I got
Okay.
42.47.
42.47 is okay. 48 is too far.
Okay.
I think it's because she rounded out, she rounded it somewhere differently other than the 83.
Yeah, so if you,
round
yeah,
at the 83%, you do get the, I think it was like 41 something.
I got 42.47 up there.
we're at 2.47, that's what most of you got, right? Is that because you're using just 72% here?
I'm using 71.98. That's
Yeah,
what's
it's
in-
because the heart rate max, instead of rounding to 193, we kept it at 192.6.
Oh, okay. I'm okay with that. That makes it more accurate. But I'm okay with you rounding to whole beats per minute too. So, actually, let's keep it my way.
Yeah, because everything will change.
We'll still get this in. Answer.
But if that's how far off you are, that's fine. Okay, so what's the unit on this number?
Milligram per
Minute,
Okay, and what is this?
is sub VO2 max.
VO2
submax.
submax. So I'm gonna plug that into the running formula.
So flat ground.
0.2 times speed is what I'm solving for. How do you know it's flat ground?
It's on a track.
I've never seen a track that has hills. Plus 0, plus 3.5. 42.31 minus 3.5. 38.3, 3.81, 0.2s. Then what?
Divide by 0.2.
194.05.
Divide by 26.
This is meters per minute, so you have to know to convert that. Divide by 26.8. 7.24 or 7.2 miles per hour.
I got 7.27 and I just rounded it to 7 miles per hour because of the treadmill.
But the treadmill can go to 7.3, but he's not on a treadmill.
Oh, so then I can.
But that's fine. Yeah, that amount of difference is fine here. Did you follow all that?
Yes.
I won't put a question this hard on the test.
That.
This is fun for the people who are understanding this.
Yep.
And once you get the concept and understand the math, there's a lot of cool things you can do. Okay, but if this freaked you out, don't worry about it. Don't spend hours and hours and hours trying to figure this out because this won't be on the test. One of the first two I gave you is more likely the level it's going to be. Okay? Any other questions on the math? Okay, let's do a quick review of fatigue before we take a break. What's the main cause of fatigue in the ATP PCR system? How long does it take to achieve that? 15 seconds at what intensity? Very high explosive intensity. And how long does it take to replenish that?
3 to 5 minutes.
Okay. What's the primary cause of fatigue in the aerobic system?
Glycogen.
And how long does it take to achieve that? 2 hours at what intensity? Low to moderate intensity. How long does it take to replenish that?
As soon as you eat, you just gotta eat.
Just eat something. So you don't have to fully replenish your glycogen in order to continue. You can just take a little glupax and a little glucose shot and you can continue exercising. But at some point you're gonna need to eat a meal to replenish your glycogen stores, to do something like that again. Primary cause of fatigue and glycolysis.
Hydrogen.
Nitrogen accumulation and
Inorganic
phosphate accumulation. How many different ways does hydrogen cause fatigue?
3.
Three different ways.
Okay, I need someone to explain one way hydrogen causes fatigue. Go ahead.
Okay, so hydrogen accumulation will increase blood pH, no, decrease
Decrease
blood
blood
pH.
pH.
And then that will inhibit PFK. And because PFK is the rate limiting enzyme for glycolysis, it'll slow down glycolysis. And then that'll slow down ATP production. And then that will slow down muscle contraction.
Yep, which is fatigue. Go ahead, Gabby.
Competitive inhibition where accumulation of hydrogen will kind of overtake calcium because hydrogen is more affinity to troponin, where hydrogen will always win against calcium, and therefore if hydrogen goes to troponin, then there would be no troponin won't get off the binding site, and so therefore there would be no power strokes, no cross bridges, no power strokes, hence no muscle contraction.
Very good. I won't mark off for this, I just want to give you a heads up going into 446, depending on who you have. If you say there's no power strokes, they'll jump down your throat just because that's too black and white. It's going to reduce the number of cross bridges and power strokes you can get. It's not necessarily all of a sudden going to be 0. So just be careful with those words. I won't mark off for something like that, but I don't like you guys to get your heads bitten off in 446. They're not as nice as I am. Okay, who has the third one? No, let's see if we can get someone else. Let me see if I can get someone else. Go ahead.
The decrease in blood pH, and we're going to inhibit phosphorylase.
Glycogen phosphorylase.
Glycogen phosphorylase, and that's gonna decrease glycogenolysis, or slow down glycogenolysis. And then after that, that's going to decrease G6P, right?
Well, it's gonna decrease glucose
glucose
first.
production, and after it's gonna decrease G6P, and then after that it's gonna inhibit the PFK, which is going to, she's distracting me. Which is going to slow glycolysis, and then it's gonna decrease ATP production, which is going to slow muscle contraction.
Which is fatigue. Very good. Any questions on any of those? You all need to be able to do that. Okay, how does inorganic phosphate cause fatigue? Go ahead, Chris.
If it's the release of calcium from the sarcoplasmic reticulum,
And why is that a problem?
there's no calcium being released and power strokes.
Why not?
Because then we'll just pull the troponin off the tropomyolis and nothing's in.
And again, it's not that we're releasing no calcium, it's we're releasing less calcium, so we get fewer cross bridges and power strokes. Awesome, well done. Okay, so at this point of the semester, rather than asking you just to recite those things back to me, I'm more likely to give you an application of it, give you a scenario, and have you figure out well, I'm gonna ask you for the cause of fatigue. In order to figure out the cause of fatigue, you gotta figure out what system the person is in, okay? So, for example, if someone is doing 10-second sprint repeats with 30 seconds rest, for 10 rounds, what's the primary cause of fatigue? Okay, glycolysis is a metabolic system, it's not a cause of fatigue. Hydrogen accumulation and phosphate accumulation, and you'd have to explain all the details of it. Does everybody understand why that is in glycolysis? Okay. What if I'm doing 30-second sprint repeats with 3 minutes rest in between each one, and I'm doing 10 rounds. Primary cause of fatigue.
Hydrogen accumulation.
Hydrogen accumulation and phosphate accumulation. Everybody understand why that's in glycolysis? Okay, just because I'm giving 3 minutes rest doesn't mean you're in the ATP PCR system. Okay. I'm running laps around a track. I'm gonna run 8 laps, which is 2 miles. And I'm going at about a 10-minute mile pace. And then I stop after 8 laps and say I'm too tired to continue. What's my main cause of fatigue? Motivation. Have I run out of glycogen? No, because I've only been running for
20 minutes.
minutes. So that's not an issue. Have I accumulated hydrogen or phosphate?
A little bit longer.
Yeah, because if I can go for 20 minutes, then I'm working aerobically. So I'm not producing lactic acid, not accumulating lactic acid. Okay, what if I do, my grandfather gets up out of his chair and walks to the kitchen. It takes him 10 seconds and he's out of breath. What's his primary cause of fatigue? I'm hearing PCR depletion and I'm hearing hydrogen. Which is it? I'm still hearing both. Let's discuss. If you think it's PCR, why do you think it's PCR? You can't answer.
Because the time period is between the 10 to 15 second window in which that's going to be the immediate energy that they're using. So it's out, and then he's out of breath, and he's trying to switch systems. And since old and probably hasn't used as much of the systems, it's harder.
Okay, if you think it's hydrogen, why do you think he's in glycolysis? Blake, you can't answer either. Because they came to classes earlier in the week, they've already gone.
If it's hydrogen accumulation, then you have lactic acid buildup, and then from there you go to the bicarbonate buffer system, and then you get a byproduct of carbon dioxide, and you're trying to exhale it, so it's way out of breath.
Yes. If you are out of breath, what system are you in? Glycolysis. Period. Let me say that again. If you are out of breath, what system are you in? Glycolysis. And he just explained why you're out of breath in glycolysis. Does everybody follow that?
So, yeah.
If you're producing lactic acid, that only happens in glycolysis. The hydrogen from the lactic acid gets picked up by the bicarbonate buffer, turns into carbonic acid, splits into water and carbon dioxide. This carbon dioxide activates the inspiratory centers in your brain that increases your breathing rate for the purpose of expiring the carbon dioxide. This is what makes you out of breath, the carbon dioxide. This is only produced because you're producing a lot of lactic acid. So anytime you're out of breath, you're in glycolysis. We can bleed in glycolysis after a 10-second sprint. If I do a 10-second sprint and I'm out of breath at the end, what system was I in? Well, it doesn't matter that it was 10 seconds. Just because it's 10 seconds doesn't mean you're in the ATP PCR system. If you're out of breath, you're in glycolysis. There's nothing in the ATP PCR system that causes you to be out of breath. Just like there's nothing in the aerobic system that causes you to be out of breath. If you do a steady state run around the track, 2 miles, 5 miles, doesn't matter. You're doing steady state and you don't do a kick at the end, you should not be out of breath when you stop. Try it next time you go for a run, if you ever go for a run. Just keep your steady state and stop without doing a kick at the end and see if you're out of breath. You won't be. Go ahead.
So does that mean when you're in the ATPCR segment and you do like a full out sprint and you're not hard breathing at the end, you have not like, you haven't built lactic acid because you haven't switched to glycolysis, so you just purely use that.
Yeah. If you do a 6-second all-out sprint, you will not be out of breath after it.
So in terms of doing the oxygen requirement and everything like that, would our oxygen requirement and our oxygen consumption be the same the whole time, or how would that work in terms of that?
You'll be an epoch after it.
After.
Well, let me rephrase that, because an epoch means your consumption's going to go up. So, think about that. there's not enough time there to get your breathing rate up from epinephrine, and there's no carbon dioxide. So, to think about how that would look on a graph. I'd have to think about that. I'm not sure. Go ahead.
Professor, so are you saying that somebody that is like really out of shape absolutely can't be in the ATP PCR system because they can't do like sprints like that or high intensity like that?
It will be very hard for someone to access their 2X fibers if they haven't accessed them in decades. You lose motor control of those fibers.
So when you're older and you're not working out?
Yes. So if you go for 40 years without ever sprinting at your top speed, your top speed will not be there anymore because you actually lose motor control of those fibers. And if you lose motor connection to those fibers just atrophy.
You use it or lose it type of phenomenon?
Exactly. Yep. I actually taught a whole class on exercise and aging back at Cal State LA 100 years ago. It was scary what happens to your body when you stop exercising. Really scary. Okay, one more example. If I'm running a marathon, let's say I'm running a 10-minute mile pace, I get to mile 20, and I can't keep running. What's my cause of fatigue? Glycogen depletion, because I've been running for 2 hours. Please don't tell me it's motivation. I just ran 20 miles, I'm highly motivated. Please don't tell me it's a motivation problem, okay? There's a physiological cause of fatigue there. Okay, let's take a 5-minute break.